Somewhere in Germany, inside a specialist conversion facility, a clean white Mercedes-Benz Sprinter waits in its original form. At first glance, it looks like any other van. Same body, same purpose-built shell, same quiet, practical design. But this one is headed toward a very different life. In the weeks ahead, it will be stripped, rebuilt, and transformed into something designed for the worst moments people ever face. This is where an ambulance begins, and the process behind it is more demanding, more precise, and more human than most people realize. Most of us only notice an ambulance when the lights come on and the siren cuts through traffic. But behind that vehicle is a long chain of decisions, fittings, checks, and tests, where even a small mistake can carry real consequences. An ambulance is not just a van with emergency lights and a stretcher in the back. It is one of the most purpose-built vehicles on the road, and the way it is made reflects that from the very beginning.
We compare the commercial rubber to the medical-grade seamless flooring. Note the subtle compression and immediate shape recovery.
Long before the tools come out, the build starts with planning. Different emergency services need different layouts, different equipment, and different power demands. So before any physical work begins, the vehicle has to be shaped around how it will actually be used in the field. Then, the base vehicle arrives. In this case, a Mercedes-Benz Sprinter. Mercedes builds the van itself, but the ambulance is created by specialist conversion companies that take that standard platform and rebuild it into something far more complex. What arrives as a cargo vehicle leaves as a mobile treatment space. Before anything is added, the shell has to be right. Once the conversion begins, every later step depends on the integrity of what came before it. Then the real transformation starts at the floor. The bare metal base is cleaned, insulated, and reinforced with a high-strength composite layer designed to handle constant weight, harsh cleaning, and years of hard daily use. On top of that goes a seamless, medical-grade floor surface built to control moisture, improve hygiene, and make cleaning fast and reliable. This is one of the first moments where the vehicle stops feeling like a van and starts feeling like a clinical space. From there, the walls begin to take shape. Custom interior panels are fabricated to hold cabinets, oxygen outlets, suction systems, lighting channels, sockets, and grab points in exactly the right places. Every panel is measured, dry-fitted, removed, adjusted, and fitted again. It can look slow from the outside, but this is the kind of precision that prevents bigger failures later.
Looks good. I'll mark the first hole.
And throughout this stage, there is a quiet kind of responsibility hanging over the work. Everyone in the building knows what this vehicle will eventually be asked to do. You can see that in the way parts are checked, aligned, and fitted with care instead of speed. Then comes one of the most critical parts of the entire build, the electrical system. A normal van electrical setup is nowhere near enough for an ambulance. This vehicle has to support lighting, communication systems, climate control, powered loading equipment, and medical devices that cannot afford to lose power in transit. That is why the patient compartment gets its own dedicated power architecture, extra batteries, charge management systems, and a carefully routed harness designed for reliability under constant stress. And in a vehicle like this, reliability is everything. A wiring mistake here is not just an inconvenience. It can affect equipment that crews depend on when seconds matter. That is why each circuit is tested on its own, then tested again as part of the full system, and then checked again under load. In this factory, verification is not a final step. It is part of the build from beginning to end. As the electrical backbone is locked in, the patient compartment starts to come alive. Cabinets are installed with equipment-specific layouts. Storage is positioned for fast access. Nothing is placed at random. The interior is designed so paramedics can work quickly, safely, and almost by instinct, even in a moving vehicle. At the center of that space is the stretcher loading system. In many modern ambulances, this is a powered mechanism that lowers, receives the stretcher, and lifts it back into the vehicle with minimal manual strain. But for that to work properly, everything has to line up exactly. The floor, rear opening, rail path, and mounting points all have to match with precision. Because if that stretcher does not move cleanly and lock securely, the consequences are serious. Outside, the vehicle is changing just as much. Light bars are mounted, siren systems are integrated, and high visibility markings are applied to strict standards. Those reflective chevrons and warning lights are not decoration. They are part of the safety system, designed to make the vehicle visible quickly, in poor weather, at night, and in the chaos of roadside emergencies. At a certain point, it starts to look ready. It starts to feel ready. But it is not ready yet, because now everything has to be tested. Every electrical function is checked. The power system is tested under load. Warning lights, sirens, outlets, and climate systems are verified. Then the vehicle is weighed because weight distribution affects braking, handling, and long-term reliability. After that comes the road test, where the team listens for vibration, movement, rattles, and anything that only shows up once the vehicle is in motion.
Okay, next page confirms voltage at this terminal.
And the ground point here, correct?
Then comes one of the harshest checks of all, the water ingress test. Pressurized water is directed at the vehicle from every angle to make sure every cut, seal, cable route, and roof fitting can survive real working conditions. Nothing moves forward until those seals hold. Only after all of that does the ambulance move into final finishing. The interior is cleaned, dickies, systems are checked again, documentation is completed, and the vehicle is prepared for handover. And when it finally leaves the factory, what rolls out is no longer just a converted van. It is a mobile emergency room built through layers of planning, fitting, testing, and verification. A machine shaped not just by engineering, but by responsibility. What makes this kind of manufacturing different is that it is slower, more deliberate, and far more hands-on than a normal high-volume vehicle line. The process depends on continuity. The same people who fit the floor may still be there when the systems are tested and the final details are signed off. That creates something rare in manufacturing: ownership. And even with all the tools, cutting systems, and digital support now used in modern conversion work, the heart of the process is still human. Machines shape the parts, but people fit them. People wire them. People test them. People make the final call that this vehicle is ready to carry someone towards survival. That is what separates an ambulance from almost any other vehicle on the road. It is not built for speed, style, or convenience. It is built to work when nothing else can fail. And the next time one passes you with lights flashing and traffic parting around it, you will know that behind that moment is a vehicle built with precision, checked with discipline, and finished by people who understood exactly what was at stake.